equation, and they're right. If we switch the x and the y, that would mean I can switch it graphically, right? I can just switch values graphically, or I can switch inside the equation, right? So I'm on page 24. I'm going to skip those example 3 and 4, just because I said it seems like most people got it. Determine algebraically, that means no graph, just use equations, which most of you prefer, we've talked about. If y equals 7x minus 3 and y equals x plus 3 over 7 are inverses of each other. Well, let's see determine algebraically. Given y equals 7x minus 3, well, the inverse is found by switching the x and y in the equation then putting it into y equals form again, solving for y. Okay, so I'm going to go ahead and I'm going to take this, it was given to me, I'm going to find the inverse algebraically, and if the inverse I find is y equals x plus 3 over 7, I know that they're inverses of each other. Alright, so this is what we're given, y equals x minus 3. I'm going to switch the x's and the y's, so if I switch places with the x and the y's, it's going to look like x equals 7y minus 3. Agreed? Now I just have to isolate y, so just like you learned way back in grade 9 or 10, I guess I'll move the 3 over, so then I have x plus 3 equals 7y. I want y isolated by itself. To get rid of 7 times y, I divide, right? So then I'm going to divide by 7, divide by 7. The 7's cancel. I'm left with y equals x plus 3 over 7. Or, I mean, right now it says x plus 3 over 7 equals y. I could easily write it as y equals x plus 3 over 7. Is that what they gave me? Yep. This is the inverse of the given function. Would this be a function? Would this pass the vertical line test? Yes. You're right. This is another linear equation, right? So I'm going to say note. This can also be written as if you want it in more familiar form, just break the 7 up, right? So I could say, okay, well that's like y equals x over 7 plus 3/7, agreed? Or, to go even further, write the 7 as a proper coefficient, 1/7 x plus 3/7. Agreed? Is that a linear equation? Yep. Y-intercept of 3/7, slope of 1 over 7, right? So they're both linear, so they would, this actually is an inverse function. It's not just an inverse. Okay, so this one says, determine if that's okay. Actually, you know what? I'm just gonna, I'm just gonna go back to the previous page. Because it said, I'm not gonna graph this, but it says, determine an equation of the inverse. Okay? So let's just do the algebra part of that one and this one first. Okay? So we did a linear inverse. Let's do a quadratic inverse. So we're given this, given y equals x minus 1 squared plus 2. Okay. The inverse is, what did I say before? Switch the x's and the y's, right? So it would start out with x equals y minus 1 all squared plus 2. Now what would you do? I want to try and isolate the y. So what do I do now? What's my next step? Move the 2 over, Joanna. So x minus 2 equals y minus 1. Yeah? Okay. Now what? I'm trying to get that y released from its brackets so that I can get rid of that 1. But I have to get rid of that square. How do I undo a square? Square root. So I'm going to square root both sides. And when I square root both sides, I have to take the positive and the negative case to get the full graph. So the square root is going to be the positive or negative case of the left-hand side. Okay, so then I have positive or negative, x minus 2 equals, the square and the square root undo each other, so I'm just left with y minus 1. Last step is just to add 1 to both sides. So I'll have y equals, I guess I could put the 1 here, 1 plus or minus x minus 2, or y equals positive or negative root x minus 2 plus 1. Okay, I'm not going to graph this, but I want you to look at this closely. Because I have the positive or the negative case, it's kind of like this is a piecewise graph. If I was going to graph this, we would have to graph both y equals the positive root of x minus 2 plus 1 and y equals the negative square root of x minus 2 plus 1. Okay, I know it looks kind of weird there because it's coming from the inverse, but do you know, can you describe what this graph looks like to me? Just describe it, because I'm not going to... What graph do you see here? What parent graph do you see? Just the square root graph, right? So it's a square root graph, what? Does it have any transformations done to it? 2 to the right and 1 up, right? So it's just the regular absolute, or the radical graph, 2 units to the right and 1 up. Agreed? What about this one? Isn't it the same graph? 2 units to the right and 1 up, but that happens after we do a reflection over the x-axis, right? So this was the square root graph reflected over the x-axis, right? Reflected over the x-axis. 2 units to the right, so reflected, 2 units to the right and 1 up. That's how you get your sideways parabola. It actually comes from the positive radical, the negative radical, and they form to give that positive. That's kind of interesting, right? Anyway, that's how we find the inverse of a radical. It's a little more complicated than a linear because of that square root. Let's try this one algebraically. So you're given y equals minus x squared plus 6. All right? Switch places. The inverse is, okay, we start with x equals minus y squared plus 6. Move the 6 over, that's our start. X minus 6 equals minus y squared. What would you do next? Get rid of that negative 1, right? I would do that too, Johannes. So divide by -1, divide by -1. That's going to give me minus x plus 6 equals y squared. And now we have that one step to do, right? We got to square root both sides. So then y equals plus or minus the square root of minus x plus 6. And that's it. That's the equation of our inverse. And this again, it's both the positive and the negative. It looks like it's a reflection over the y with a shift. Now, you could try graphing these maybe for part of your homework, and then I'll put the answers on the blog. So this one, part B, is almost the exact same, right? It's minus x squared plus 3 instead of plus 6. But it's saying only invert half of the graph. They only want the positive side of the graph. So basically, that's only going to give you one arm of the graph. So it says determine algebraically whether the functions. So if I did a quick sketch of this, this would be a parabola, what, of vertex at 0, positive 3, right? And it would open down, okay? So basically what they're saying is just determine whether the functions y equals minus x squared plus 3, but only the positive arm. So they're just basically saying to you, you're not even going to, they don't want you to even worry about this. Like if you were going to reproduce the graph, they just want this arm, just the positive part where x is greater than 0. They just want the piece of the graph where x is greater than 0. All that means is, given y equals minus x squared plus 3, the inverse is found by x equals minus y squared plus 3. So I'm going to move the 3 over. Then I'm going to divide by -1 to get rid of that negative sign. Minus x plus 3. Okay, then I'm going to square root. Now because they restricted, they just want the positive side. So what they're saying to me is they don't want the positive or negative root, they want the positive root. That's the only difference, right? Because of this, they're limiting. I'm only going to do half of the equation, half of the graph. So finally, y equals root negative x plus 3, or if I was really interested in graphing this, because I have 2 changes on x, I have to factor out the negative sign. And that's what I would graph. So I'd only graph one arm, I guess, of the function. So it's a radical graph, flipped over the y-axis, shifted 3 to the right. And that's how we handle inverses. So they're just another type of reflection, but there's way more to do with an inverse, because you can be asked to graph it, which is pretty easy. You just pick a couple of critical points, switch the x's to the y's. Or you can be asked to find the equation algebraically. Graphing is way easier in this case than the algebra, I think, because you have to switch the x's and the y's and then solve for y. So it does get a little tricky. There is an assignment in your chapter book about reflections and inverses together, and there's more notes. If you need a little more notes, you can read them or watch the videos over. And it's on, this is where your book kind of got weird. So I had to photocopy another page if you came late, come and get it. You can do this example in the book, the page, the separate sheets, page 44, 45, and 46, and that's in your stapled book. So it's a 3-page assignment. If you get that done, if you flip to the back, there's a little practice chapter test too you can work on as well over the weekend. Okay. And here, and like I say, there's lots of notes embedded in this book, so just flip pages, the pages between the assignments give lots of other information. And then the last thing I'll tell you, if anyone wants more feedback from me, I have a short little 2-pager. If you want, you can work on that too. You've got 3 days on the weekend, so you might want to leave your chapter book to the weekend. If you want to hand this in to me, I can give you some feedback today again too, if you want to do that. It's up to you, okay? And of course, we've got the rest of the class too.